The mysteries surrounding 3 Atlas continue to grow, with new puzzles surfacing that demand our attention. The latest revelations about this object are nothing short of extraordinary, beginning with the sheer scale of its size and mass. One of the primary conundrums stems from its size, which is 1 billion metric tons. To put that into perspective, that's 5 orders of magnitude larger than the final mass of the famous interstellar visitor Oumuamua. If we are to believe the conventional models, we should have discovered around 100,000 interstellar objects of a similar size before encountering something as massive as 3 Atlas. Yet, here we are, faced with a mysterious object that's unlike anything we've seen before. As 3 Atlas approaches its closest pass near Jupiter on its way out of our solar system, we are left with more questions than answers. Could this flyby hold the key to understanding its true nature? Unfortunately, it's likely that we won't gain many insights into its origin or structure from this encounter. But that doesn't mean we give up. If anything, it only fuels the curiosity to explore more about this enigmatic visitor. The question we need to ask is, can we hope to learn more about interstellar visitors like 3 Atlas, or will we continue to be left in the dark? To truly understand these objects, we need to examine them under extreme conditions, specifically when they pass close to the Sun. In fact, one of the most promising ways to study objects like 3 Atlas is through sun-grazing trajectories. These events are rare, but they provide invaluable insights. For example, in 2019, I co-authored a paper with my former postdoc, John Forbes, in which we explored the statistics of close encounters between interstellar objects and the Sun. We discovered that objects like Oumuamua, which are similar in nature, collide with the Sun about once every 30 years. When these objects pass close to the Sun, they experience intense heat that vaporizes any solid surface, revealing the inner workings of their structure. This gives scientists an unprecedented opportunity to analyze the composition and behavior of such objects. One of the most intriguing opportunities is coming up soon. On April 4th, 2026, we'll have the rare chance to witness another sun-grazing encounter, this time with an object known as C2026A1 MAPS. This object was discovered on January 13th, 2026, from the AMACS-1 observatory in Chile, and it will pass incredibly close to the Sun. Specifically, C2026A1 will come within just 161,000 kilometers, about 23.1% of the Sun's radius. This will be a significant event, and we can expect to witness it from Earth as the object moves in front of the Sun. The exact timings are important. The object will enter solar conjunction behind the Sun at 1319 UTC and will appear in front of the Sun at 1534 UTC, separated by just 0.04 degrees from the Sun's center. What makes this object so intriguing is its unusual trajectory. While its size and mass are comparable to 3 Atlas, its orbital characteristics are quite different. C2026A1's orbit suggests that it's part of a group of comets that are gravitationally bound to the Sun, but its path differs significantly from other known members of this group. The object's diameter is just under 2.4 kilometers, and its orbital inclination of 144.5 degrees is about 30.6 degrees away from 3 Atlas's own inclination. Despite these differences, there are still intriguing questions about whether C2026A1 could be a fragment that broke off from 3 Atlas during its journey through our solar system. However, this idea doesn't hold up upon closer inspection. If C2026A1 were a fragment of 3 Atlas, we would expect it to share more characteristics with the original object. But this isn't the case. Nonetheless, its trajectory suggests that it could provide valuable insights into the nature of interstellar visitors. On April 4th, 2026, The object will reach perihelion, its closest point to the Sun, at an impressive speed of 557 kilometers per second, roughly 0.2% of the speed of light. When it makes its closest approach to Earth on April 5th, 2026, it will be just 143.8 million kilometers away, or about 96.1% of the Sun's distance from Earth. This is a prime opportunity to observe how the object behaves as it comes into contact with the Sun's intense radiation. As C2026A1 MAPS draws closer to the Sun, it will burn up and break apart, giving us a front-row seat to what could be one of the most spectacular cosmic events in recent history. This is when we will learn the most about the object's composition and material strength. The way it responds to the Sun's heat will provide crucial details that will help us understand the fundamental properties of interstellar objects. It's moments like this that truly test our models of the universe, as we are forced to confront the unknown and push the boundaries of scientific discovery. But it's not just scientists who are intrigued by C2026A1 maps. Recently, I received a deeply thoughtful email from a member of the public who took the time to reflect on my work in the field. The email, written by a person named Chris, expressed gratitude for my intellectual courage in challenging the conventional wisdom of the scientific community. It was an uplifting message, one that reminded me of why I do this work. Chris and his family praised my efforts to question the status quo and refused to dismiss the unexplained. Their words were a powerful reminder that the pursuit of truth, no matter how uncomfortable, is worth the effort. In the message, Chris and his family discussed the numerous anomalies surrounding 3 Atlas and how they had applied the same sense of curiosity to other interstellar objects passing through our solar system. One of the main points they raised was the lack of media coverage about C2026A1 maps. While it had been categorized as just another sun grazer, its unusual behavior defied easy explanation. Chris pointed out that the object's orbital period, which is nearly 1,900 years, was much longer than any other known sun-grazing comets. The fact that it was detected so far from the Sun, at a distance greater than 2 astronomical units, suggested that it was unusually large or active. Moreover, its brightness was increasing at a rate that defied conventional expectations. This led Chris to ask some important questions. Chris's email raised several compelling questions that are worth exploring further. Firstly, he asked whether C2026A1 maps should be treated as an unclassified object until better data is available. Given the numerous anomalies surrounding its behavior, it may indeed be premature to categorize it alongside other known sun-grazers. The second question posed was whether its runaway brightening could indicate something unusual about its composition or structure that standard cometary models don't account for. This is an intriguing possibility, one that could lead to a rethinking of how we understand these cosmic visitors. Finally, Chris asked whether this object could survive its close encounter with the Sun and put on an incredible display for observers on Earth. If it does, we'll have a chance to witness one of the greatest astronomical events in recent memory. These questions highlight the need for further investigation into the true nature of C2026A1 maps. As we move forward, it's clear that we must remain open to new ideas and be willing to challenge the assumptions that have guided our understanding of the universe. The answers to these questions could reshape our view of interstellar objects and their role in the cosmos. The email from Chris was followed by another intriguing message, this time from the poet Alan Wagstaff in New Zealand. In his response, Alan shared his thoughts on confirmation bias in science, a topic I have frequently addressed in my work. His email was a bit humorous, but it conveyed an important point about how the scientific community often dismisses ideas that don't fit neatly into established models. Alan's witty response was a reminder that even in the face of skepticism, we must continue to question and seek the truth. As we approach these cosmic events, it's crucial that we remain curious and open-minded. The mysteries of objects like 3 Atlas and C, 2026 A1 maps, may hold the keys to unlocking a deeper understanding of the universe. We must be ready to explore these mysteries with the same intellectual courage that has driven scientists like Chris, Alan, and myself to continue searching for answers. If you're fascinated by the mysteries of interstellar objects and want to stay updated on the latest discoveries, make sure to hit the subscribe button and turn on notifications. You don't want to miss the next big revelation.